Hi guys, today we're gonna do this is chapter 1 test part 5. So this part is gonna be really quick because we're only gonna do three questions. So let's begin. So yeah, this is part 5 of chapter 1 test. So the first question says solve. So yeah, 3 questions. So we're gonna solve by using square root properties. So my first question is, we have a, so we have s1 plus s plus 1 squared equals 5, and we got to solve for s. So we got to use the square root property. So what I'm going to do is, for question A, is I'm going to take the square root of both sides, because my goal is to solve for s, right? So take the square root of both sides. So what happens when you take the square root of a square? Like, you get just regular x. So over here, we're just going to get s plus 1. The square root cancel. Like, when you take the square root of a square, it just becomes 1, so you're just left with s plus 1, right? Now, when you take the square root of a whole number like 5, you're going to get two parts. You're going to get two answers. You're going to get a plus or minus. And then a square root of 5 is not, it's actually a smaller number. It doesn't come out evenly, so you could just leave it out as square root of 5. Now, we said that my goal is to solve for s, so what I'm going to do is subtract 1 from both sides. Note, and keep in mind that on the right side we have two parts, a plus, positive square root of 5, and a negative square root of 5, so keep that in mind. So let me put it right here. So you're going to get s equals positive square root of 5, and remember you have a minus 1, so it's a minus 1, and then our other s is going to be, remember we have two parts, negative square root of 5, and then don't forget to minus that 1. Okay, so this is your two answers, right? Pretty simple, right? So s equals square root of 5 minus 1, and then s equals negative square root of 5 minus 1. So just remember, when you take the square root of a whole number, like 5, you're going to get two answers. Let's do B. Let's say we have n minus 3 square equals negative 4, right? My goal is to solve for n by using the square root property. So what am I going to do first? My first step is to get rid of this square, so I'm going to take the square root of both sides. You're probably asking, if you ever get like curious, why is it that when you take the square root of a square, it just cancels? The reason why is, like, you can rewrite as negative n minus 3 square, and then that square root, it's the same thing, is equivalent as saying raising it to the 1/2 power, right? And remember, when you're raising exponents, you're really multiplying, so it's like that when you multiply the exponents 2 times 1/2, you're just left with 1. That's how you get n minus 3 to the first power. If you ever can get confused for that. So when you take the square root of this, you get n minus 3. Now over here, this is a little bit different. Remember, you can never have a negative in the square root, in the radical. So what you have to do is you have to factor out an I, right? So you can never have a negative, so you have to factor out an I. So this is going to be plus or minus, right? You get two answers, plus or minus I square root of 4. Okay. Let's see here. Let's wait. Before we add 3 to the right side, let's simplify the right side. So this becomes a plus or minus I. Now remember, the square root of 4 is just 2, so you can rewrite that as plus or minus 2i. There we go. Now we simplify the right, and let's solve for n. So we got to add 3 to both parts. So let me put it right here. So n equals plus or minus 2i plus 3. So if you were simplified, it would be positive 2i plus 3, and then you have negative 2i plus 3. So those are your two answers. So we're dealing with imaginary numbers. Right? Let's do C. So C says we have c squared plus 9, equals 0. So we got to solve for C by using the square root property. So let's look at the left side. We have c squared plus 9. Now don't get confused. This is not a perfect square. It could be a perfect, it would be a perfect square if it was c squared minus 9, but it's not, right? It's c squared plus 9, so it's not a perfect square. So what are you going to do here? Let me rewrite it again. C squared plus 9 equals 0. So yeah, this is not a perfect square. So what I would do is, so I can't factor it, so what I'm going to do is subtract 9 from both sides. So you get c squared equals negative 9. Now, I got to solve for c, so I'm going to take the square root of both sides. So you get c equals, now remember, you cannot have a negative inside the radicand, so you have to factor out an I. And when you take the square root, you get two parts. You get a positive and a negative. So c equals plus or minus I, and then the square root of 9 is 3. So we can rewrite that as positive 3i and negative 3i. Okay, so that was C. Now let's do one problem where we're solving quadratic formula. So this will be our last one. So this one is, we're not going to use a square root property. We're going to do a complete different. We're going to solve using quadratic formula. I'm only going to do one problem using quadratic formula because you only need to do one, right? So you're given, this is D, 9s squared plus 7 equals 125, right? So we got to solve using quadratic formula. So how I would do this is I would get the right side 0. I'm going to set this polynomial into the right, I'm going to put this in standard form. By standard form I mean the right side 0, so I'm going to subtract 125 from both sides. Oops, excuse me. This is not 125, this is 12s. It looks like it looks like a 125, but it's just 12s. So this is just 12s. So yeah, now I just want to get rid of this 12s, so I'm going to move it to the left side by subtracting 12s from both sides. So I'm left with 9s squared. I'm going to put it in order, so my next order would be negative 12s plus 7 equals 0. Now I have it in standard form, or I have the right side equals 0. Now I can use the quadratic formula. And so I got to figure out what's my A, what's my B, and what's my C. So your A is the highest degree, but it's not it's the coefficient of the highest degree. So our highest degree is the square, so our coefficient is just 9. What about my second highest degree, which would be s because this has a 1, but it's not the 1 degree we're looking for, it's the coefficient, so that we're left with negative 12. And then our second highest, our lowest degree, which is 7, because that's like saying 7 to the 0 power, and we know 0, whoops, it's like that 7 is like saying 7 to the s of the 0 power, because we know that anything to the 0 power is 1, and then 1 times 7 is 7, so that's how you get 7. So it's not the degree we're looking for, we're looking for the coefficient of the 0 degree, which is 7. Now remember, the quadratic formula is x equals opposite of b plus or minus root b squared minus 4ac all over 2a. Okay. So we just got to put it in the formula. So x equals, where's my b? Negative 12. So the opposite of negative 12 is positive 12, right? Plus or minus. And I'm just going to do little by little, so I'm not going to do it all at once. So we got, what is negative 12? So b squared is negative 12 squared minus 4 times ac. Notice that they're really close. That means multiplication. So 4 times, with my a is 9. What is my c? 7. All over 2a, which is 2 times a, which is 9. Now let's simplify. (12) plus or minus negative 12 squared is positive 144. Now it's like saying negative 4 times 9 times 7, which is negative 252. All over 2 times 9 is 18. Okay, let me go down. So it's like saying x equals 12 plus or minus 144 minus 252 is a negative number, right? It's negative 108 all over 18. And remember, you can never have a negative side the radicand, so we got to simplify that. How do we simplify it? We factor out an I. Let's factor it out in I. 12 plus or minus I square root of 108 all over 18. Okay, let's focus on this 108. We can actually simplify that 108 by two numbers multiply 108 is 9 and 12. Let's see here. That's 9 can be simplified as 3 times 3. And that 12 can be simplified as 4 times 3. And then that 4 simplifies as 2 and 2, right? Let's see here. What is my prime? 3. Now, remember in when you see pairs of 2, like here we have pairs of 2 here and pairs of 3, you only have to write it once, so we're left with 3 times 2, which is 6. So that 6 is going to be outside the radicand. So it's going to be 12 plus or minus, remember, don't forget this I, so it's like saying 6 times I, which is 6i. And then you're left with the prime, inside the radicand, you're left with the prime, which is 3. Let me box that. All over 18. We're almost done. We just got to break it into two parts. So we said that x equals, we have two parts. Remember, we have a plus or minus, so it's going to be 12 plus 6i all over square root of 3 all over 18. And then my other answer is x equals 12 minus 6i square root of 3 all over 18. We're almost done. We just gotta, we can actually do a little bit more simplification. Let's focus, okay, so on the numerator, we have a 12 plus 6i times square root of 3. Can we take anything out? We can factor out an x, so 6 times, if we factor out a 6 from the numerator, so it's going to be 6 times 2 is 12 plus 1i, or you could just leave it as I, square root of 3, all over 18. And we could do the same thing as here. What can we factor out on the numerator? We can factor out a 6, so it's 6 times 2, and it's going to be minus, not positive, because we need a negative 6, minus 6i square root of 3 all over 18. And then let's see here, we can simplify. Let's look at the numerator and denominator. We have a 6 and an 18. This can be reduced, right? This cancels and you're just left with 3, right? Yeah, 6, it's like saying 6 over 18. It just reduces to 1 over 3, right? So you're left with 1 times this, which is just 2 plus I square root of 3 divided all over 3 now. And then over here, it's the same thing. This reduces to 1 and this reduces to 3. So this is just 2 minus I square root of 3 all over 3. So these are your two answers. And that is a quadratic formula. So that wraps it up for this part 5.